So much for coming tonight. I know it's a little bit drizzling outside unexpectedly, but thanks a lot. Before we start, and we have a quick show of hands, just want to know more about the audience. How many of you guys are actively engaged with augmented reality, AR? Okay, good, good. How many of you would self-classify yourselves as technical? And that's a very loose term as well. So, okay. How many of you are PhDs? I'm just throwing out there. I should be seeing some of our speakers actually as well. Okay, cool. I just want to understand a little bit more about the audience as well for our speakers before we go in pretty deep. In terms of format, how we do, actually before we begin, I want to introduce the team first. So how many of you, is this the first ARCV event that you've been to? Okay, probably intros are in order. My name is Shang Wang. I am one of the moderators tonight, one of the co-organizers, along with Jesse as well as Anna of ARCV. We typically do these kind of meetups once a month or so. We've been slightly more silent this year because Anna, our fearless leader, has been in monk mode for the past quarter or so. But now we're back, and of course back with a bang with no other than Magic Leap, the gentleman basically in front where we're going to be speaking today. And in terms of the format for what we're going to go through tonight is we're going to start with one-on-one fireside chats with our speakers, so you'll be able to get to know them as individuals first, and then we're going to bring them all back for a panel around more of an industry level type of discussion around computer vision as well as embedded vision and algorithms. Sound good? Cool, awesome. So before we start, just a quick word about sponsors. First of all, thanks to Anna with Epic. Anna, do you want to quickly describe what you do? No? Okay. She's still in stealth mode after, she's waking up after monk mode after 3 months. So
I'm not actually woke yet.
All right,
technically, but
hopefully after this event, right?
Yeah,
okay.
Yeah, it'll be soon.
And then, of course, thanks a lot for UC Berkeley Extension, which is a really great venue that we've been hosting a lot of these meetups in, actually. And as a fellow Cal alum myself, along with Jesse, it's really good to be back and also giving back to the community and building an ecosystem around UC Berkeley. Thanks a lot. And I'm Fred, if you're watching this, Fred is one of the directors for this program. Thanks a lot for sponsoring us. And Surfy, which is the company that I'm part of. So I'm actually the head of business operations at Surfy, which basically maps out the entire world in 3D and allows devices on the ground, for example, your mobile phones or maybe even Magic Leap ones, to be able to localize themselves in outdoor environments. So we do all of the localization as well as the 3D mapping actually using satellite imagery. That is actually our top-down approach versus a more traditional SLAM approach. Happy to go more into the nitty-gritties basically afterwards as well. But we are hiring at the moment. Basically, we have 3 lanes, roughly, 3 different categories that we're hiring for. Computer vision and deep learning, and then infrastructure and Ignite, and then finally Unity and front end. Those are the rough 3 categories we're currently hiring for. If you guys fit any of these, please talk to me afterwards. We'd love to talk to you more about what we do. And of course, tonight is not about necessarily us, me, or the sponsors. It's about Magic Leap, and this is why you guys are here for. So our first speaker is going to be Helder Suzuki. Helder, where are you? There you go. Okay, cool. So you got the seat right here. And Helder, I know you kind of got surprise dragged in last minute by your colleagues, essentially.
Yeah.
But you are the engineering director at Magic Leap, where you are running the real-time spatial perception pipeline from research to product launch and beyond, which sounds really, really cool. But I was wondering if you can go a little bit more, I guess, deeper into what you do. But maybe first we can start with your background. I guess how did you get started in AR or computer vision? And where are you from?
Yes. So how did I start? I joined in 2015. I met back then I was still working at Google.
Right. Actually, let's go even way back. Actually, before, not how you started with Magic Leap. Actually, maybe around school time or something. How did you get inspired by computer vision or engineering in general?
Oh, I actually didn't know anything about computer vision until I joined Magic Leap.
Okay, all right. So do tell, do tell. Okay.
Yeah. Well, yeah, that's my journey into the Silicon Valley was when I joined Google. I was fascinated about how much power you can get by aggregating data from the internet. There's so much data out there.
Yeah.
And today we all use that to just take for granted. Then 2015, that's when I found out about Magic Leap and that this kind of like trend. It's like a, how should I say, secular trend where you get cheaper and cheaper sensors, mobile computing getting more and more powerful.
Yeah.
So all of a sudden, the whole industry is set up such that you can have a lot of mobile devices capturing a lot of data from the environment, right? And just beginning to have enough processing power to do something about it. And if you add up like all the devices in this room, all these phones, they're capturing a lot of data, right? If you turn on all the cameras, that's, I don't know, gigabytes of data per second. And if you compare it to scale of mobile, how much devices are there, it's orders of magnitudes more than the internet itself, right? Because of how much new data.
Exactly.
So that was like, okay, that seems like a good future getting.
Yeah, definitely.
That's how I ended up in Magic Leap.
Okay, well, so tell me more about that transition, basically. So what exactly were you doing at Google, and then how did you come across Magic Leap, and what has that journey been like?
Yeah, so at Google I was working something completely different. It was natural language processing, search engine. So some people might have used Google Scholar. So it's like a search engine for academic papers.
Exactly.
So the input there is like.
I think when I search your guys' names, I think Google Scholar actually probably comes up as one of the top results, if not the top one. So good job with the paper writing and citations.
Yeah, so the input from Google Scholar is basically text from the internet, and the output is also text to the internet.
Right.
You know, it's text to text. And then in Magic Leap, our input are pixels or light, right? Which is instant, and our output is also light.
Right.
So that's kind of like end-to-end.
Sure.
You go back from the edge to the edge.
Okay, got it. And so what are you currently doing with Magic
Leap? Basically work on all the privatization, right, in the computer vision stack, and a lot of exciting stuff. The real power is actually making that available, right, to the mass.
I guess like how do you do that? Can you walk us through, I guess, from research what it takes to actually make it production ready? Because during our brief chat before this, it sounds like you kind of make things more production ready compared to the top level research.
Yes. So like any product that we release, there is some degree of polish, right? It kind of has to work, and needs to handle corner cases and so forth. But the actual killer feature for most of those is actually speed, right? If I can search on the internet, but it takes me a whole day to do a query, it's not useful.
Makes sense. Yeah.
Same with any kind of mobile application. If I could do SLAM, but it's taking 1 frame per second.
Yeah.
And if you go back in the literature like 15 years ago, we actually had that, right? Those kind of things.
Right.
But it's not in a format that is useful and deployable. So it's all about making it faster, more power efficient, and take advantage of the latest computer technologies.
So speaking of speed, actually, and feel free to let me know if you can share this, but what is one instance where I guess like what do users from a SLAM perspective, right? How fast does it need to be before a user loses their patience and gives up on going like, this doesn't actually work?
I would say a fraction of a millisecond is
really
to be visible.
Okay.
Yes.
That's actually like kind of humanly imperceptible almost, right?
No, it's actually pretty.
Is it? Okay.
Yeah, our eyes actually that we found out is very good at perceiving very small differences.
I see.
If
Okay.
something is misplaced, especially if you're wearing a device, it becomes really obvious. Like a millisecond difference actually impacts how you perceive. I mean, of course, depending on the person, some person might be more or less sensitive.
Right.
And you can compare that to, let's say, autonomous driving application.
Yeah.
If your car is 1 millisecond off, it's probably okay, right?
Right.
Because you also don't know your car should be driving in that kind of range.
Okay.
But yeah, in our case, it's more visible.
Yeah. And so you said that that threshold is what, like 1 millisecond?
A fraction of a millisecond.
Fraction of a millisecond. Okay. So, and this is the production ready, right? Like threshold.
Yeah.
So what about the, I guess, the code that you started with, the raw code that you started with before making it production ready?
It can be good enough to give a demo.
Okay.
The
Basically,
person-
tell the audience, just wait for it. Just wait for it. It's gonna happen.
Yeah.
Right.
No, you try and say, oh yeah, it takes a little bit longer. It's not quite right.
Okay.
There's still ways to go, right, in the whole stack,
Mm-hmm.
but it's getting to the point where I think it'll be ready.
Got it. I see. And so moving towards something a little bit more personal, which is, what are some of the biggest challenges that you have encountered in your career so far?
The biggest challenge is, I would say my work in Magic Leap has been the most challenging so far.
Okay. Yeah.
Definitely stretching.
But in a good way.
No, in a very good way.
Yeah.
Basically going back to all the fundamentals,
Mm-hmm.
computer vision, computing, computer architecture,
Mm-hmm.
taking advantage of what's out there in terms of compute platforms.
Yeah.
It's literally the bleeding edge.
Definitely. Well, that's really interesting. You're probably the first person who has actually, took that challenge question that I've asked in a positive way. And I think that kind of speaks to your mentality too, which is like, give me more challenges. It's like, Google's not challenging enough. Let's join Magic Leap for the biggest challenges, that we can solve.
I mean, there's already a lot of cloud applications,
Right.
but we want to do that without sending all your data to the cloud.
Definitely.
And I think it's definitely the new frontier.
Yeah, for sure. Well, I'm definitely very excited to hear more during the panel as well. And thank you so much for coming up here.
Thank you.
Awesome. Thank you. Next we have Ali Shah Rockney. Thank you so much. You got the seat. So we actually got your profile, so I'll go through that. Ali is a lead embedded software engineer at Magic Leap. Algorithms team, where he received his PhD in computer vision from EPFL Switzerland and a postdoc from a robotics lab at Oxford. He has over a decade of industrial and academic research experience in computer vision for 3D reconstruction and mixed reality. He has worked at Amazon Lab 126 and Broadcom as part of their embedded computer vision team prior to joining Magic Leap. Outside work, he enjoys long distance road cycling, amateur carpentry, we'll definitely get into that, photography, and spending time with his wife and 2 boys. Please welcome Ali. Cool. So, I think we're going to start with your background as well. Tell me more about yourself and how you got started in this field.
I did my PhD in computer vision at EPFL under Professor Pascal Fua, who's quite well known in the field.
Right.
And I remember that was back in early 2000, and one of the first projects that I was working on was to turn a cardboard box into a lightsaber.
Turn
a box into a lightsaber,
Okay.
augmented reality, and that was back in early 2000. So that was
early 2000s.
yes, that was one
Okay.
of the first projects actually. Our lab was part of the virtual reality and computer graphics lab,
Oh, amazing.
and had computer vision emphasis as well to it. And another very cool project that one of my colleagues worked on was to create a 3D model of a face that was from a single camera.
Right.
And then it was used to add the virtual objects to it, like a mustache or goggles in real time.
It's like pre-Snapchat, face detection AR, which is
Fascinating to
Okay.
see these things now coming into ubiquitous products.
definitely.
Yeah.
Do you ever, I guess, go, watch the current trend of social AR stuff and go, what are your thoughts around that? Do you go man, I did that 10 years ago?
But I don't know if I did it. But yeah, so lots of things that started decades ago are now quite off the shelf products
I
and
see.
everyday things that we take for granted. And it take decades of research to reach this point, which is fascinating.
Okay. Next time I do a Snapchat face filter, I will think about you and all the hard work that actually went into making that possible, actually.
Okay.
All the doggy ears and everything, so. And for those in the audience who's not familiar with embedded vision or embedded algorithms software, can you explain a bit more about what that is?
Yeah, so embedded software is the software that is written to run a dedicated piece of hardware, an embedded system, to be more specific. And an embedded system is basically a system designed for custom tasks, tailored for specific applications, not general compute. And it generally has limited hardware, limited compute, limited memory resources, and
it has to run on device.
Absolutely, it has to. Yeah, it has to cope with a lot of constraints. Yeah.
Right, I see. And what are some of the most significant advancements in embedded software? Well, actually, both on the hardware and software side.
Yeah, so that's yeah, it's amazing the level of compute that we can have now on mobile phones. It matches, you know, PCs. And I was just looking at the costs of gigaflops, so that's the number of kind of operations that you can have in a clock cycle.
Right.
And the cost per gigaflop was around millions of dollars back in 80s, and now it's like around 3 cents.
3 cents?
Yeah.
Okay.
So that's fascinating.
That's amazing.
And yeah, so I mean, the amount of compute you can get, the amount of connectivity, the cloud backend processing that you can have to support what you're doing on the phone, so like all the beautifications that happen on the pictures that we take, both on the device and then the post-process things that we get from the cloud, machine learning that can occur on the phone in real time, like face detection, all the filters, etc. And the synthetic aperture, for example, that you can get on the device. This is pretty fascinating that they can actually kind of match DSLR quality.
Yeah, with the bokeh and everything.
Pictures, which has this amazing optics and all the expensive lenses to capture all the light, but with very tiny lenses on mobile phones. They're pretty much making DSLRs redundant, which is fascinating.
Right, and a lot of the sensors these days on small phones can almost see the dark.
Absolutely.
It's amazing. And moving away from embedded vision for a moment, and you lived in UK for like almost over 10 years, right? And started with Oxford and everything. And you've been here in the Valley since 2015. How would you contrast or compare, you know, the computer vision community or even tech in general, you know, between these two regions?
Yeah, I mean, it's quite different. Here, Silicon Valley is, of course, great. It's as a powerhouse of the latest and greatest in technology. But over there are centers of excellence that are, world-class institutes that can produce, you know, world-class technology and research that then get exported here. And I think in general is slower pace, I would say, over there in Europe in general, which is not necessarily a bad thing because it allows for more well-thought development and research. And lots of amazing things have come from there. And actually, like for example, around Cambridge area only, it's over there it's referred to as Silicon Fen as opposed to Silicon Valley. And it's not very popular because probably not so many people know what a fen is, but
can you explain that?
It's marshlands.
Marshland. Okay, so it's like in marshland.
Yeah, it's quite flat and rainy, as you can imagine.
Yes, that's right. It's UK after all.
Yeah. So I mean, it's a small town, Cambridge, and it produces a lot of top research and also technology. For example, ARM, which is
that's right.
All 90% of cameras on embedded devices or systems, SoCs or system on chips are ARM IP. Our Raspberry Pi computer, which is a credit card size computer, very cheap and can be used for educational purposes and also other technologies.
Oh, nice. Yeah, thanks a lot for sharing that perspective. Both your bio picture and your profile basically featured cycling. So I'm also a cyclist myself. Not necessarily, probably not as hardcore as you, but can you share some adventures you've had on long distance cycling?
Oh yeah, sure. I mean, thanks to Magic Leap, which has offices in nice place around the world. I recently went for a visit to our Swiss office, and then I
Swiss office.
Yeah, so
I can only imagine how beautiful that would be.
It is, yes. Actually, we have two offices, one in Zurich in the German-speaking area, and one in Lausanne, which is in the French part. And actually, incidentally, is where I did my PhD, so it was nice to go back. And anyway, so I took a weekend to go on one of these mountain passes called Albola Pass, which is along the railway line that is spiral kind of bridges and tunnels to basically to be able for the trains to defy gravity. And it was quite significant. I could hear the Alpine horn as well being played, and it was like a 7,000 feet climb, which is
wait, on your bike or train?
On the bike.
On the bike.
I did on the bike. You can do that.
Okay, I was gonna say I'll probably see you, on the train waving to you as I pass by, but 7,000 feet of elevation climb. Oh my gosh, over how many miles?
It's 40, around 50 miles, I would say. Yeah.
Okay. Anything that is over, like 1,000 feet per 10 miles, I consider that pretty steep.
Take it easy, and I didn't say how fast I did. So.
All right, well, I'll be on my lowest gear for sure. And I definitely, mentioned at the beginning that we'll get into carpentry. Tell us more about that.
That's something I sort of picked up out of necessity. Anything is I wanted to build something, stuff around the house.
Necessity? Like you had to know your own furniture?
Well, not that much, but I just felt like I needed something I couldn't find, and so I just watched some videos on YouTube. I wish I could one day use Magic device to train.
Right? That would be a perfect use case, actually.
Absolutely.
Come on, guys.
And, so that's kind of how I got into it, and I found it quite relaxing and enjoyable thing to do. Yeah.
Very cool.
Yeah.
Well, thank you for sharing all of that. Thanks a lot. Yeah, definitely. All right, so next we have Ashwin. Okay. Ashwin leads the team at Magic Leap researching world sensing, simultaneously localization and mapping, otherwise known as SLAM, object recognition, visual inertial odometry, and scene semantics. We'll definitely get into all of that in a bit. Prior to joining Magic Leap, he was with Qualcomm Research for 7 years, where he was involved with various computer vision and machine learning projects for applications in AR and context-aware computing on mobile devices. He was also involved with Qualcomm's efforts in robotics and drones. I'm dying to ask about that. Ashwin holds a PhD from University of Maryland and holds over 30 patents in the field of computer vision, machine learning, and augmented reality. He has authored 7 journal papers and over 30 conference papers that have been cited more than 3,000 times. So it's definitely not a coincidence when I looked you up. It was Google Scholar. That was literally the first link that got to you. So, all right, please give it up for Ashwin. So tell us a little bit more about yourself. How you got started in the field?
So I joined University of Maryland and then into Qualcomm. So I started at University of Maryland. I was working on a completely different area. I was working on image forensics and fingerprinting, more along lines of privacy and security of images. If you're familiar with steganography, that's the kind of stuff that I was doing at Maryland. So, and then I moved to Qualcomm, and I started working on this. This was back in 2008, 2009 timeframe. So I started working on augmented reality. So it was quite interesting. So I kind of came into this space by chance in the augmented reality space. The first project that I was put on at Qualcomm was to detect objects and just track the objects on a frame-to-frame basis. So I found that quite interesting, and then that was something that Qualcomm demoed at in the NBA playoffs in April of 2011.
Yeah,
it was way before augmented reality became a thing.
Definitely.
So we had this demo where people coming to the NBA game can take their tickets, turn around, and so we had a picture, and that was the object that we were tracking.
Right.
And then you can place your entire basketball stadium on the ticket and overlay it on top of your ticket. And so you can see it with a Qualcomm phone and then experience augmented reality with that.
Right.
So
you mentioned a Qualcomm phone.
a
Like-
Qualcomm phone with a Qualcomm chipset.
I see. Okay, got it. And I mean, Qualcomm has had a very rich history with AR. I mean, especially with V4 is probably the most well known. Did you ever have any intersections with that team?
So I was part of the research team
I see.
who was providing algorithms to Euphoria, and
Got it.
Euphoria was the prioritization effort that was
Mhm.
sending our stuff to the market.
I see. Okay. And at Magic Leap, you're primarily working currently on post tracking.
Right. So then, so I was working on multiple projects in Qualcomm, and
Yeah.
was there for till around 2015 when I
Mhm.
joined Magic Leap.
Yeah.
So at that point, so Qualcomm was building the whole SDK around augmented reality,
Mhm.
and I wanted to do something which is more end-to-end, something which
Right.
will be able to take all the algorithms, all the research that we're doing, and take it all the way to product, and
Yeah.
build a complete end-to-end integrated solution.
Right.
And Magic Leap was this company that was just coming up, which had gotten the first round, the second round of funding, I think, at that
It was
point.
like super early days.
It was very
right?
early
Like
days at that point.
2012.
2015 is when I
2015.
joined
Okay, I
Magic
see.
Leap.
Yeah.
So it seemed like a very interesting company, and it's been interesting the last 3.5 years that I've been at Magic Leap has been amazing.
Right.
We've done a lot of very cool stuff from the point where when I joined Magic Leap to now where we have a product out in the market. We have a demo set up for you guys and there are some stuff that I'm going to show you that we've not shown before.
That's
so
right.
stay along to see the demos as well.
I actually should have mentioned that. Thank you for reminding me, which is, yeah, if you guys see a whole bunch of Magic Leap glasses, it's because of these gentlemen, essentially.
And we have a lot of people from Magic Leap as well.
Yeah.
So I want to give a shout out to them for coming in and helping out with all the demos.
So if you are all dying to try out Magic Leap on your own, this is tonight
This is
is
a
the
good
chance
opportunity, yes.
for sure, definitely. And for those in the audience who are less familiar with post tracking, can you describe what that is and why that is important for AR?
So in computer vision, so we work on multiple different topics in computer vision at
Yeah.
Magic Leap. So post tracking is one of them.
Right.
So post tracking is traditionally known as inside out tracking. So the basic idea is that you want to be able to localize the user with respect to your environment.
Right.
And you use your environment to help you localize the user. So you build a map of your environment. More, you can think of like corners or edges and things like that in your map, and then you use those to localize yourself back.
I see.
And the basic idea is that you want your content to stay in the same place where you left it, and you want to be able to exactly know where the user is at every point of time, so that you can place the content in the same location.
Got it.
So that's the underlying algorithms behind that is like computer vision community is known as SLAM. So
Yeah.
we work on simultaneous localization and mapping to be able to build a map of the environment and localize the user against that.
Exactly. So post tracking is basically one of the building blocks for that.
Post tracking is one of the big ones.
I see. Got it. And so, talk to me a little bit more about drones, actually, when you were working at Qualcomm, because I know that was part of the major projects that you were working with.
So in Qualcomm was a chipset provider. So the computer, like I was saying, I was part of the core computer vision team.
Yes.
And as a computer vision team, we were building the core technologies, and
Yeah.
we didn't, and it was used for multiple kinds of verticals. So AR and VR was one such vertical where we were commercializing our work through Euphoria SDK.
I see.
And then, but the same SLAM or the same reconstruction algorithms can also be used for other verticals. Like, so we spent some time looking into drones,
Right.
implementing our SLAM solution or other kinds of world reconstruction, or computer vision technologies on drone platforms. The same thing for land robot use cases.
Yeah.
Everything is slightly different in terms of the computer vision requirements. So in AR and VR, you kind of place your in AR, especially you place your content against the world. So
Yeah.
so the requirements on inside out tracking are very different because if your object is slightly up not on the table but slightly above the table, you notice that. In drones, it's much more different. So it's you don't care too much about the exact location of the object as long as I don't hit against the wall.
Right. If you're
I'm
not like
okay.
crashing the things, okay.
Exactly. So
Yeah.
so the core technology is kind of similar, but the implementation or what is more important in terms of how the product is very different.
Got it. I see.
So we are kind of optimizing our stack towards different or each of these verticals so that we support multiple kinds of use cases.
I see, got it. And that's part of the joys of actually probably being in research as well, because what you're working on has so many broad applications.
Right.
I
So that was part of my growth at Qualcomm, and then magically I'll be involved more to take the research all the way to product, working with both researchers and product teams as well.
Right, got it. And so moving more into a little bit more personal question, which is, what has been really influential in your career?
So I think it's a combination of different things. So being involved in this AR market for AR industry for some time now,
Right.
and just to see the stuff that we work on a day-to-day basis go into product and being used by people,
Yeah.
and getting feedback in terms of what's worked, what's not worked, and each time an SDK goes out in the market, we're always looking into forums to find out what kind of
I
comments
see.
we're going to get
Right.
from the SDK. So that's actually been helpful for us in terms of that kind of feedback to see what's interesting to people, what kind of things people care about.
I see.
And also we have a great team to work with at Magic Leap, and that keeps us going in terms of on a day-to-day work to make sure that we are always on top of our game.
No, for sure, definitely. I mean, before I came in, I saw you guys in a circle over there, and you guys just, were laughing, having a lot of fun, just like, colleagues and friends.
Yeah, we're trying to
Yeah.
set up all the demos so that you guys have a good time.
Right, exactly. Well, thanks a lot, Ashwin. Really appreciate it.
Thank you so much.
Definitely. We'll see you.
And
back
thanks
here.
for you guys for inviting us as well.
Thank you. Yeah, definitely. Right. Next up, we have Pratik Singhal. Cool. Awesome. Please. Pratik is a lead computer vision research engineer at Magic Leap, focusing on seeing, understanding, and object recognition using different modalities like depth cameras, RGB cameras, and IMU. He previously led the team for large-scale persistence. He is also one of the core members of the head pose team and have worked on core tracking and mapping algorithms for Magic Leap 1. Prior to Magic Leap, he got his master's from Georgia Tech, where he was working with Dr. Hendrik Christensen and published on integrating object tracking and multiple objects using SLAM to create semantically rich maps. He also worked on dynamic motion segmentation for autonomous vehicles at IIIT Hyderabad. Welcome, Pratik. All right, so I think you know the drill now. We can probably start with your background so that the audience knows a little bit about where you came from.
Sure. So I did my master's from Georgia Tech. I started out in CV as an undergrad, back in India in undergrad, they have these small competitions where you try to make a robot follow a line, basically like these mine detectors. And so in my second year of undergrad, I started doing that and I really liked it. So I started doing more of research into that and started first initially working on things like face detection and action recognition. And then I did one of my summer internships in undergrad at IIT Hyderabad, which is like a top vision institute in India, and worked on things like SLAM and like how do you make in that case it was an autonomous car C to localize itself, and that's how I've been working in this field for almost 5-6 years now.
I see. And in terms of seeing, understanding, and object recognition, can you go into a little bit more detail about what they are as well as how they impact AR?